touch briefly on at the end of last class. All right, so most of last class was devoted to conditional proof. And in conditional proof, we introduced the idea of assuming things. So for example, if you're going to do conditional proof for this one, which probably makes sense, what do you assume? What's that? A. Why do you assume A? Because it's the antecedent of the conclusion. So you say A and you say S. All right, and then what is strange about this line, of course, is that I have indented it. Why have I indented it?
To remind yourself that it's not actually in the real world.
Right. When you indent, you indicate that you have left reality behind. Reality is over here. Everything that you write on over here is true. You're given the premises, we assume that they are true. Everything that you derive logically from something true has to be true. But you don't know that this is true. You're just making it up. You're just pretending. You're assuming that it's true. So you can't write it over here in the privileged space for things you know that are true. You have to indent it to indicate that you have left reality behind. You have entered fantasy land. All right. Now, I continue in fantasy land until, let's say, let's say line 88. Let's hope not, because I have to grade that thing. What will be my last line in Fantasyland if this is conditional proof? That's Z. Why will it be Z? Yes, because what we've done is we've assumed A is true. We said, what if A is true? Well, if A is true, then this follows, and then this follows, and then this follows, and this follows. And if we can show that Z is one of the things that follow, if A were true, then we have shown back in the real world, so let's say Z, and we don't know how we got Z. Well, actually, we will get Z by simplification, line 87. I know that for a fact, except it won't be 87 and 88 for you, I hope to God. All right, so we go back to the real world on line 89, and what do we write? If whatever we wrote on our first line, which was the antecedent, then whatever we wrote on our last line, by what?
Conditional proof.
Conditional proof, what line references?
5 through 87.
5 through 88, all the indented lines, that's right. So we have proved in reality that if A were true, then Z would be true. That is something we know really, because we said, let's imagine that A is true, what follows logically? So we've shown that if A were true, then Z would also be true. We've shown that, without showing that A is actually true. But that's not what we're claiming here. We're not claiming that A is actually true. All right, so with conditional proof, we introduced this notion of assuming, of making stuff up, entering fantasy land. That is also used in Reductio ad absurdum. In Reductio ad absurdum, what does Reductio ad absurdum mean again?
Making contradiction.
That's not what Reductio ad absurdum means. I mean, you're telling me something true and useful, but not the answer to my question.
Reducing it to absurdity.
Reduced to an absurdity. That's right. So Reductio ad absurdum means reduced to an absurdity. And what it means is, it's actually a way of disproving something. So, whereas before we were concerned with proving things, with Reductio ad absurdum, we're concerned with disproving things. And as I said last time, this is a strategy that you will have used in actual arguments you've actually had with actual people. You will have said, they will say something that you think is stupid, and to illustrate its stupidity, you will illustrate that if it is true, then something even more obviously stupid would also be true. And because they reject the even more obviously stupid thing, they have to also reject the thing they've just said. So, for example, suppose you wanted to disprove P. A way to disprove P is to show that what follows from it logically is a contradiction. What contradiction? Does it have to involve P? No. It just has to be any contradiction. Why a contradiction?
Because contradictions cannot be true.
Right, because contradictions are self-evidently false. They cannot ever be true. And a contradiction is something and the negation of that same thing. And as we know from our truth table of conjunction, that can't be true. Because the only way for a conjunction to be true is if they're both true. And even if we don't know what this is, it has to be true or false. If it's true, then this is false, and the whole thing is false. If it's false, then the whole thing is false. So there is no way for a contradiction to possibly be true. But notice, so in other words, it has to be false. We know that that is false. But if this is false, and we've reached it from this by logically valid steps, what do we know about this? Remember, well, what do we know about validity? What is impossible in a valid argument?
True premises that lead to a false conclusion.
Right. In a valid argument, it is impossible to have true premises in a false conclusion. Remember, that's the basis of the shortcut test for validity. You cannot possibly have true premises in a false conclusion. Well, we know this is a valid argument because we've started with this and we've arrived at this using the rules, the 19 rules, and they are all valid. We know that if we've done this right, we've started from here and we've used all of the correct rules and arrived here, then this whole thing will be a valid argument. It's a valid argument with a false conclusion. That means this cannot be true. Because if it was true, then this would have to be true. Because in a valid argument, if the premises are true, oh, and incidentally, if this is true, it confers its truth on every single one that follows. So given that this ends up being false, this has to be false to begin with. So what you've done, by showing that this assumption leads to something that has to be false, you've shown that this assumption must itself be false. So that's why it's a method of disproving. And that's why, incidentally, you have to do all of this in fantasy land. Because remember, everything you write in the real world has to be true. But you know this can't possibly be true. So it can't be happening in the real world. So the way that reductio ad absurdum works is you assume what it is you want to disprove, and you show that it leads to a contradiction. If it leads to a contradiction, you have effectively disproved it. But wait a minute. If you have disproved P, what have you proved?
Not P.
You've proved not P. If you've shown that P is false, you can say back in the real world, suppose this is line 10, then back in the real world, you have shown that not P is true. How have you shown it? Let's say this is line 3. You've shown it by reductio ad absurdum, RA, all the indented lines, 3 through 10. So that's how reductio ad absurdum works. You start by assuming what you want to disprove, and that's your first, so that's the assumption. And instead of writing as, you write ARA, just to indicate that you're doing the same thing as you're doing in conditional proof. You're assuming. But this just gives me a clue that you're assuming it for the purpose of doing reductio ad absurdum. Maybe I should make you write ACP if you're doing conditional proof. But then you won't get to write as, and that's always fun. Okay, so you're assuming this, and then you demonstrate that it leads to a contradiction. Any contradiction. Doesn't matter what the contradiction is. And then you go back to the real world, and you've proved not P. There is something a little bit strange about this. For one thing, unlike with conditional proof, what you write here has absolutely nothing to do with this. This could be Z and not Z. And you don't mention them at all in the next line, because it doesn't really matter what goes on here, except that it be a contradiction. Doesn't matter what contradiction it is. The only function this shows is to illustrate that this is false. So what you have proved has nothing to do with whatever this is. That's one slight strangeness about it. Okay. What is the value of reductio ad absurdum? Well, it has sort of a, I think its pluses outweigh its minuses. Here is the downside to reductio ad absurdum. Unlike both conditional proof and regular non-assuming proof, you don't know what you're trying to get. In regular non-assuming proof, what are you trying to get? The conclusion, right? So you've got to arrive at the conclusion. That's why you can do what I call the top-down method, and you can sort of look at the conclusion and work backwards. How am I going to get the conclusion out? Well, I need to get it out of there, I need this. To get that, I need this. To get that, I need this. You sort of work backwards. You can't do that with reductio ad absurdum because you don't know what it is you're trying to get. You know it's a contradiction, but you don't know if it involves P, Q, R, S, whatever. You don't know what it involves. So you can't do the top-down method. So you have to do what I've called the bottom-up method, which is just to mess around, just to apply rules and see what happens. So you're sort of stumbling around aimlessly, seeing what happens when you're doing reductio ad absurdum. That sounds like a major downside, but it has its upsides. And the upsides are, and here is the major benefit of reductio ad absurdum, there are many more possible correct solutions, because there will be one way to get to do it when you've got P and not P. Somebody else will do it where they've got Q and not Q. They're both equally good. You just have to get a contradiction. It could be Z and not Z. It could be if P then Q and not if P then Q. That's a contradiction as well. So there are many more possible successful solutions. Consequently, it's a lot harder to get stuck. You've probably already had the experience of getting stuck doing proofs either the conditional proof way or the regular way, because there's one thing you have to get and you can't see how to get it. Whereas with this, there's not one thing you have to get. There's a contradiction, but it could be any contradiction. So normally I would say reductio ad absurdum is kind of a last resort. Try and do it the other way. If you get stuck doing it in the other way, then at the point at which you get stuck, jump into fantasy land. Assume the negation of the conclusion and see if that helps you. So you could do a proof all the way down, do like 20 steps of the proof and then say, oh, screw it, I'm stuck. And then jump into fantasy land and see if that helps you. See if that can give you a contradiction. So reductio ad absurdum, pluses and minuses, but that's how it works, and that's why it works. All right, let's illustrate it working. And I'm going to do something a little weird. I'm going to, thanks, Susan. I'm going to do reductio ad absurdum on a proof that is actually in the exercises for conditional proof. Now, it's in the exercises for conditional proof, this is question 4 on page 391, because it's actually pretty quick to prove using conditional proof. In fact, let's do it with conditional proof just for shits and giggles, as they say. All right, if we're doing it with conditional proof, what do we assume?
Assume D.
We assume D, because it's the antecedent of the conclusion. What can D do for us now that we've got D?
Modus ponens.
We can do modus ponens not once, but twice, because it is the antecedent of both the premises. Now we have if E then F, and if F then G. What immediately suggests itself to you who have now memorized all 19 rules? What's that? Hypothetical syllogism, which will give us what?
E then G.
E then G. That's right. How many more lines will our proof have? Just one, because we had to assume the antecedent and try and get the consequent of the conclusion. We've got the consequent of the conclusion, so what do we do?
Declare victory.
Declare victory. How do we do that? Write yay next to it, and a smiley
Jump
face.
back into reality on line 7 and declare if D then E then G.
By conditional proof, the indented lines. Yes, so that's how you would do it with conditional proof. Now, it's a lot longer and more ugly with reductio ad absurdum, but I just wanted to illustrate that you can do reductio ad absurdum on effectively anything. Even proofs where the conclusion is a conditional. So, if we're going to do this by reductio ad absurdum, again we assume. What do we assume? We assume what we want to disprove, and what we want to disprove is the negation of the conclusion. Because if we disprove the negation of the conclusion, what have we proved? The conclusion. That's right. So that's going to be a bit ugly. And be careful when you do this. Don't just stick a negation in front of the D. Stick a negation and apply it to the entire line. So it's going to look like that. Now, right away, that looks kind of ugly, and you think to yourself, this is going to be a bit of an ordeal. But, you know, don't panic. Because when you have the negation of a conditional, you want to get rid of the negation in the parentheses. What rule, hint, my favorite, do you use? What's that? Implication. And in fact, this is where you do implication and turn it into a conjunction. Remember, there are 3 stages to that. First stage, replace the conditional with a conjunction. Second stage, what? Negate the one on the right, so you're going to have a tilde in front of that. Third stage, negate the whole thing. Now you can either just add another tilde around here and then get rid of it one line later with double negation, or you can just say that's going to erase that negation. So actually it gives you a conjunction, which is useful. We always like conjunctions because we can then simplify them. Word of warning though. I'm giving you an illustration of where we do implication and then we do simplification. The old imp-simp. Don't get too comfortable with this method because this is a very common mistake. People see a conditional and they think, oh, I want D. Well, I can get it by imp-simp. No. If you have a regular old conditional, you can't get it by doing this. It's only if you have the negation of a conditional that you can do this. So if you just have if D then E, if you do imp to that, you don't have a conjunction, you have the negation of a conjunction, which you cannot simplify. So do not think that this is going to be a commonly used strategy. You only use it when you have the negation of a conditional. There, word of warning aside. Alright, well now we have this, we can also do the same thing to that. We can do imp, and now we've got another conjunction that we can use. Alright, now, where are we going with this? We have no idea, because this is reductio ad absurdum. We're just seeing what we can do. We're just messing around until suddenly we get a contradiction. So what can I do? Well, there's a D there. Why don't I use that D for modus ponens again? So basically now we've already seen this strategy because it's what we used with the conditional proof. Now, I also, though, doing this method, I have got an E. So if I simplify an E, I can do modus ponens with that. So simplify the E, do modus ponens, and I get an F. Ooh, and now I've got an F, I can do modus ponens again and get what? G. So again, why am I doing this? I don't know. I'm just trying to get stuff, right? I'm doing what I can do. I'm doing what suggests itself to me, and then I'm stumbling around and seeing if I can get a contradiction. And in fact, a contradiction is very close. I have the needed materials to make a contradiction. What are they? What's that? Well, no, remember, I'm trying to make a contradiction. So I need to have something and the negation of that same thing. And I've got it.
But you do the simplification
Yes, I'm going to have to do simplification of 6 to get what? Not G, because I have G. And then, so not G, simplification of 6. And then what is going to be the rule that you will use on the last indented line of the vast majority of reductio ad absurdum? Conjunction, yes, because what you will do is you'll get the thing on one line and then its negation on another, and then to make the contradiction, you conjoin them. So in nearly all reductio ad absurdums, your last indented line is a conjunction. All right, so what do I write on line 15? By reductio ad absurdum 3 through 14 in this case. Oops, that was from conditional proof. Yeah, so like that. Notice that it's a hell of a lot longer than the conditional proof. Partly because we didn't know what we were doing. Yes?
Could you have done with 8 and 9 a hypothetical syllogism?
Sure. Yeah, I could do a hypothetical syllogism and then get F that way.
Oh, could you have done like a conjunction with line 5 to get if E then G and?
Very good. Yes, that would actually be quicker, wouldn't it? Yeah, so I could have saved a couple of lines. Let's just illustrate what he's talking about. So, on line 10, we have F, E, then G. This pen is getting a bit weird. If E then G by hypothetical syllogism 8, 9, and then he's already noticed that we have the negation of that on line 5. So line 11 would be if E then G and not if E then G by conjunction of lines 10, 5. And then we go back out to reality and we proved it by. That's good. So we've seen that there are 2 ways to prove this. And that's always the case with the reductio ad absurdum. I'm sure you could come up with other ways. You could probably get D and not D. You could probably get E and not E. Lots of different ways. And notice that it's pretty simple stuff. We don't use, I just use modus ponens and simplification and I guess imp there. Like 3 or 4 rules tops. It wasn't very complicated. So reductio ad absurdum is a good fallback. It tends to get you out of a jam. Okay? Why don't you, all right, I think that'll do it. Why don't you get out